back, and we're kind of going through a library of interesting functions that we're going to need to be very familiar with to be able to be successful in calculus. And here's the trig function that we use to model periodicity. I've drawn the sine function. Again, it's an odd function. It's between its its range is bound between 1 and -1. The domain goes, in the last example, I acted like it stopped. It's the domain is for all real numbers. So dot, dot, dot goes through that. Now, what happens when I multiply that by 2? I amplify things. Well, as you might say, we're just like we do on any function. If I amplify it now, it's going to, I'm not going to shift, I'm going to amplify. I'm going to amplify, so it's going to go between -2 and 1. So I guess I can draw some points here. It's going to come down. Okay, and so on, and I'm going to come down here. Okay. So what is this? This is, it's been amplified or stretched 2 times the sine of x. Okay. What happens to this function when I do this? I have 5. I change the input. Now I've actually got a composite function, but this changes the, increases the frequency, right? Increases frequency. Makes a higher pitched sound if you're actually going to play that out in your speaker. Or it reduces the period. The period of a sine function. Again, this period here is what? Well, the period here we might call t was 2 pi. Now it's going to be 2 pi over 5. And it's going to be difficult for me to draw, I realize here. But basically, I'm going to have 5 periods. I'm going to have 5 periods involved. In fact, I realized how difficult this will be to draw, such that I'm going to change the problem and make this make that a 2. So I can demonstrate to you what's going on. 2. I'm going to make that a 2. I still need a green one here, don't I? Now I just need to get 2 periods in place of 1. So I want this half as much here. Okay, I went ahead and drew in my function here. Oops, picked my pen. I had to stop a little bit, make sure I didn't mess that up. But here, this is 2 times the sine of 2x. Okay, it's amplified or stretched by a factor of 2, and the period is twice as much. Meaning, this thing, the period now, see, it repeats. It repeats t equals pi. So you'll see there's 2 full cycles. Notice the red. The red has 1 complete cycle in 2 pi radians. The green has 2 complete cycles. So the frequency is doubled. The period has been cut in half. Again, this goes on forever. This is what? It's still an odd function. So I could take this whole function and reflect it here. And I won't do it accurately here, but, you know, something like that, okay? So that's kind of the sketch of these two. And again, I would get the intercepts. I'd get the intercepts and then draw the peaks in between. Okay, so we've amplified and we've changed the frequency. If this was half, you know, if this was 1/2, the frequency would reduce and the period would increase. Okay, we looked at sine and cosines to model periodicity. I didn't show you a tangent function, but you should be able to handle drawing a tangent function also, as we will perform calculus on that. The tangent function has some interesting vertical asymptotes you should be able to handle. But the next function we'll talk about here are exponential functions, which we use to model growth and decay. That first thing says y to the 5x. That's a 5 there, believe it or not. That's a 5. And how do you draw that? Well, notice at x equal to 0, it's equal to 1. So I'll always put all these exponential functions. You put in a 0, you get 1. Okay. Notice how it's going to shoot up relatively fast. Maybe a little table here might be useful. X, 5 to the x. At 0, it's equal to 1. At 1, it's equal to 5. At 2, it's equal to 25. At 3, it's equal to what? Well, 5 to the third is 1. 5 cubed is 125. So this thing shoots up quickly. This is very steep. If we talk about the slope here, it's very steep. Now what happens if it goes negative? What about minus 1? Well, minus 1 is just going to be 0.2. What about minus 2? Minus 2 is going to be 1/25. So 4 minus 3 is going to be equal to 1 over 125. This is equal to 1 over 25. This is equal to 1 over 5. This is what? 1 over 5 cubed. Okay, so this is getting, as you can see, what happens as x goes to negative infinity, what's going to happen? As this gets minus 4 or minus 20, this number is getting smaller and smaller and smaller. It's going towards 0. Again, we're going to talk about limits in the next chapter, but this is going towards 0. So this is a function 5 to the x. Okay. Well, that's good. What about, how about e to the x, though? Remember, e to the x, what is e to the x? Let me change my pen. E is just a number, what is it, 2.714, yada, 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 versus this was 5. Okay? So, at 0, it's going to be equal to 1, but at 1, you know, let's see, I guess I could do this. What's e to the x? This is going to be 1. This is e. This is e squared, which is less than 9. You know, e is 2.714. It's just a number. So this is going to, it's going to be less than that, but still go up fast. Okay, and then one over here, this is going to be 1 over 2.714, 1 over e squared, 1 over e cubed. Okay, so this is going to be a little bit higher on this side, right? Because 1 over e squared is less than 1/9, which is greater than 1/25. So you got to convince yourself that that slope, but it still has the same tendencies. This thing is still going to 0 as x goes to negative infinity out here. Okay. What about, how about the last one here now? Let's finish this one. What about 5 to the minus x? Well, this, it turns out to be, we're going to reflect this axis. What happens if you put in a 0, it's still 0. If you put in a positive x now, positive x is going to go like the negative side. Right? So if you put in a plus 2 here, you put in a 2, it's going to be, if I put in a 2, it's going to be like 1 over 5 squared. Right? And if I put in a, and over here, if I put in a, let's call this minus 1, it's going to be minus 1. And what happens when I put in a minus 1? Well, that's like 5. Minus 1 is going to be 5 to to the negative -1, which is a positive 1. So this is -1, 5. Okay, so you see what happens when you put negative x. It reflects it. Again, it's going to take that and reflect it to this. Reflects it around the y-axis. So again, can you draw these? What's the point of this exercise? Do you know what an exponential function looks like? You know the shape of it? Notice an exponential function never goes negative. So the range, another thing you should know about these, here's a common point you should realize. Know how it grows fast, decays to 0 over here. And the range, y, is always greater than 0 and less than infinity. So an exponential function, unless I put a negative scale factor, is always going to be positive. Okay, see you in the next video. We still have to sketch log functions, and then we'll be done with this section. See you soon.